Hello and welcome to this session on the user interface of ANSYS Fluent. So after having an idea already about the basic user interface of a given CFD software, we're going to focus now on ANSYS Fluent. So what I'm expecting from you is that you're already familiar with basic terms of CFD and the different approaches how we can derive numerical solutions to transport equations, how CFD software usually operate, what are the different requirements that they have, and I hope by the end of this lecture that you can answer questions regarding how you can navigate through the user interface of ANSYS Fluent and what are the different options available for you to interact and execute a given CFD project. So in this presentation, you will be getting to know what are the different components of the user interface in ANSYS Fluent, the GUI and the TUI based components, the graphical user interface and text user interface, just as a reminder. And we'll also look at the user interface components from the point of view of the tasks that they fulfill, the purpose or the goal that they are there for. And we'll also see how ANSYS Fluent can be operated with other software packages through interoperability options in a workbench environment as well as through data exchange. So I hope you can remember this slide from the previous presentation. So basically any CFD software should have components which can perform these tasks. So I mean the tasks in the sense of importing and exporting files. It should have options for representing what is the basic workflow. It should have a menu bar, a toolbar for shortcut, and of course you should have the possibility to see the results. That's a graphics window. And we are also expecting that you should be able to interact through a text user interface with the software, wherein you can define the boundary conditions and the details of the different numerics of the given problem. So you have a GUI and a TUI based CFD software UI, which is usually what you encounter. And now let's look at what happens in the case of ANSYS Fluent specifically. So the UI components in ANSYS Fluent again are classified through GUI and TUI components. So we'll look at what are the basic GUI components. First of all, we have a launcher. So that's ANSYS Fluent's specialty since 12 release. So we have a launcher, and once we launch the CFD software ANSYS Fluent, we get different GUI options in terms of the menu bar, the model tree, some control panels, and some toolbars which are embedded within the GUI, and of course the graphics window, which may or may not be embedded within the GUI, which can also be taken out of the GUI that you encounter at the launch of the ANSYS Fluent session. Additionally, we also have the console window. I'm going to speak about it, how using the text user interface you can interact with the software efficiently and perform some operations which are a bit hidden to the general purpose user. And we also have a dialog box. This is what I called earlier as the details pane. So ANSYS Fluent calls it a dialog box in which you can feed in the details, in which you can directly interact and make some changes to the software, to the specific case. So when I launch ANSYS Fluent, when I double click on the ANSYS Fluent icon on my desktop, or if I launch it through a text user interface on a Unix or Linux based operating system, in that case the launcher is what you get at the first, and you have an option here called the show more options. When I click on that, the options begin to appear, the extra options that you have. But basically what you can see here in the launcher is a choice of the kind of solver, a two-dimensional or a three-dimensional problem, and we have options for single or a double precision. If I don't select anything here, I basically mean that it's a single precision solver. I'll be speaking about it later on in a lecture on the fundamentals of the solver, where I'll explain how double precision increases the accuracy of the problem in certain cases. But overall, this is the launcher. You can see the working directory where you can start your problem, and there is a root path from where the Fluent is actually being launched. When I click on OK, then the graphics window appears. So this is the overall graphics window after having imported a mesh. So the typical terms that I use, the menu bar is visible here, the toolbar, which is the shortcut to the graphical user interface options. It has a general tree which describes the set of operations that have to be performed in a given simulation. We have the controls panel which describes the specific selection on the model tree here, and this is the graphics window which is very visible. And when I want to modify one of the components within the controls panel, what opens up is a dialog box. So this is where I can feed in details. I can give what is the velocity at the inlet, or the other parameters which might be required for boundary condition definition. So overall, the menu bar at the top is actually organized in a way that you will usually implement different projects, but from the 12 release, Fluent also offers to us a good tree-based architecture where you can see what are the different steps to be followed. This is basically inspired by many other competitors which have included the tree-based approach to the GUI. So once we are into the console window, apart from the menu bar, what we have also something which is very interesting is the console window. Now this is a terminal emulator for the TUI mode. What you can do is many of the options that you can access through the menu bar, you can also access all of them using the TUI. Of course, it's not so easy because it's more based on inputting data in terms of the keyboard values that you need to give. Of course, it's not so convenient that you have to give specific inputs through typing the specific commands, but overall it's very powerful because there are many hidden features which are available only through the TUI mode, through the console window option. And it's also very interesting because at any level it works on the principle of levels. So as you can see here, at present here we are at level 0, and when we press enter, we can see the different options which are available, and we don't need to even type the whole command. We can just type F, and you can see here in the whole list we have only file to be one of the options, starting with the letter F, and we don't need to type FILE. We just type F and you arrive at file, and when you press enter you can see the different options which are available within file. There are some specific models which are available only through the text user interface. They are not available on the general GUI, so therefore it's very helpful for an advanced user to operate with the software using the text user interface. Now let's look at the software architecture. We are already familiar with this chart, the purpose-driven options that you have in the components of the CFD software, and we are going to focus a bit more on the file input-output options available in ANSYS Fluent. So what we have here is, first of all, when we go to file read, we can read in the different kinds of meshes and the case and data. So I'll speak about this in a bit more in detail a few slides later about the different data handling options in ANSYS Fluent. But as of now, you can see that there is a mesh option, there is a case and data option. These are the file formats which are possible within ANSYS Fluent. You can import and you can also write them. So you have below read, you have also the option of write, and we can read or write them, but we can also import other kinds of files from other software packages, third-party software packages, and this is also part of the interoperability of ANSYS Fluent. We can also export files to third-party software. So a given CFD simulation, we can export it to be readable for maybe, let's say, a code which can read something called the CGNS file, which is CFD general notation system. So it's very helpful to export data from Fluent for evaluation in the third-party software. So this is one of the interoperability options, part of the file input and output in ANSYS Fluent. We can also do a lot of modifications and analysis of the given mesh which has been imported. So you have the options to check the quality, the size, the different options of if you want to make some modifications in the mesh. You can see if you can separate some zones, we can merge some zones, we can translate the mesh, we can scale the mesh. So these options are also available in the mesh modifications panel in ANSYS Fluent. So we've looked at the file input output options and some modifications at the mesh level. Let's look at what happens at the physics model based inputs which are required in ANSYS Fluent. So we're looking at the overall architecture of ANSYS Fluent from the perspective of physics based models. So the options that are available are huge. Actually, this whole section of the model tree that you see in the screen, starting from general and specific models, materials panel, physics based boundary conditions, and cell zone conditions, that is what kind of equations are to be solved inside the domain. Also defining mesh interfaces and defining some reference values for calculations of some dimensionless quantities, performing dynamic mesh operations. So all these options are available within ANSYS Fluent for defining the physics models. So that's a very important feature of ANSYS Fluent. Additionally, we also expect the software to ask us inputs regarding the numerical schemes. For numerical schemes, there are different steps involved in ANSYS Fluent. So first of all, we define what kind of approach we are going to follow to solve the transport equations of flow and other transport equations. So you have the choice of solver in terms of pressure based and density based solver. And once that is done, we move on to this section of the GUI of the tree. So the first option that you see is because of general selection here. You can access all of them by define and solve options as well. But once we go into the solutions section, we can see options for the type in which the finite volume based code has to operate. So basically finite volume method is what is ANSYS Fluent following at the back end, but there are some modifications for the way in which the equations can be solved. So some modifications to achieve accuracy. Solver mathematics lecture will explain more this in more detail. And you have options for solution methods. We can initialize the problem once the solution process has been set up, and once the initialization has been done, which is can be done through standard initialization or hybrid initialization, which is new in ANSYS Fluent release 13, which solves the potential flow solver and gets a good initialization for even for multi-phase flows. And once that is done, we start simulating, we start iterating the problem, because CFD is an iterative process because of the numerical schemes. We are solving nonlinear equations, converting them into linear algebraic form. Therefore, the overall solution process is an iterative one, and we try to achieve some convergence ultimately. Now, there are some new advances in ANSYS Fluent 13 onwards, wherein you can see an option called the pseudo-transient approach. This is basically inspired by CFX. I'll be discussing this more in detail when we speak about the solver mathematics of ANSYS Fluent. But in the pseudo-transient approach, we try to approach the solution of the problem not by the conventional iterative manner, which is basically what many finite volume based textbooks speak about it. But what we do is we define that even a steady state problem we try to approach in a pseudo-transient manner, and in this case what we end up giving to the software is an option for the time step, the steps in which you are proceeding towards the steady state solution. So you have to perform the iteration still, but you define a time step, and this is very stable, especially for the coupled form of equations where the flow equations, that is the continuity and the three momentum equations, are coupled together. It's very helpful to have a very stable solution process. So ANSYS Fluent has all the options which are currently popular in the industry, in the software industry as of now, for CFD solutions. Once we are done with the numerical schemes of the software, let's also have a look at how the data handling and post-processing can be performed in ANSYS Fluent. So we are looking at a variety of data handling options. So let's first of all understand the different file formats, the basic file formats that ANSYS Fluent deals with. Now, as we saw in the one of the first few slides about the different kinds of mesh and case and data files that ANSYS Fluent can import or export, read or write. So these are the three basic file formats: mesh file, which is a .msh file, the case file, which is .cas file, and the data file, .dat file. The .msh file basically contains only the mesh. It does not contain any description about the problem. So this is what you actually write after the pre-processing step, and this .msh file is readable for ANSYS Fluent. ANSYS Fluent reads the .msh file, and now after the mesh has been read into the Fluent GUI, after this, when we write any file, what we'll write is a case file. The case file contains the unstructured mesh which has been generated. Unstructured meaning every cell has its own name. It's not stored in an IJK format as a typical structured mesh, but it's an unstructured mesh. So the case file does contain the mesh file, but additionally it also contains information about the setting of the problem in terms of physics models, the numerical schemes, even the display settings are stored in the case file. And once the whole setting is simulated and we generate data at each and every cell point, that data is written in a data file. This data file is usually an outcome when we write the data file. Otherwise, Fluent stores it in the random access memory of the computer. So once we write it, we have a data file which we can read also later on. Certain things need to be understood about the case and data files, especially that actually the complete simulation process along with the results is understood by ANSYS Fluent only when you read in the case and the data file. So let's say I do a simulation, I need to write the case and data file so that I can retrieve the data at a later stage. So a data file on its own does not have any sense. It has to be accompanied together with a case file, and only then ANSYS Fluent can display to you the results, because it's the case file which contains ultimately the mesh file and the different physics settings. So let's say you generate a data file and you do not have the case file. You can just mitigate this problem of the absence of a case file by just reading in the mesh file, and then that data is superimposed on each and every point which is available in the mesh.